Hello, I'm Tuomo Kalliokoski, a doctoral researcher at University of Jyväskylä and the organizer of AI-JKL meetup group. Unfortunately, the live recording of my presentation failed, and I had to record this presentation offline. This presentation has some corrections compared to the live one, and here we go. Never trust the data, it is always incorrect. Outline of this talk is following. We have about 25 slides. We start with a small introduction on who I am. Second stop is physics with measurements and units. Then we discuss on how vagueness of terminology can affect measurements. We also cover some issues with polling, internet questionnaires, and non-ASCII data. As this is an AI-related talk, there is also a part on how the bad data used in the training causes problems in the end product. And sometimes we must work with not only bad data, but purposefully incorrect data. And finally, we have some discussion on how to mitigate these issues. My personal background is in physics, where I have masters in theoretical physics, and my work was related to the ALICE experiment at CERN. After that, I worked as an experimental physicist in continuing with ALICE and then Laguna and Kuppe/EMMA projects. After a short stint as an entrepreneur, I did a master's in mathematical information technology, and this also included some statistics studies. And this is the scary physics part. If you are measuring something, you affect the subject of being measured and change the other things in it. You can never have full information of any system, as the system changes as things are measured. And the more relevant side of the physics is the physics of the measurement device. All measuring devices, starting from human senses to the detector stations in CERN, have the physical limitations which affect the measurement. Each detector has a response to signal, which can be too low to be observed if the signal is not large enough. There will be calibration issues. Detector can saturate and you miss events during the dead time. And there are blind spots where you don't get the signal at all, like when sitting in a car, some structural parts are blocking your view. One primary error source is the use of incorrect measuring device. Different multimeters have different capabilities when measuring, for example, alternative current voltages on different AC hertzes. More hands-on example is different measuring tools for distance or length. You can measure width of a sofa with a 50 cm ruler, but there will be a huge error margin in the result compared to a 2-meter tape measurer. For sub-millimeter distances, a caliper is a lot better tool than an old and battered 15 cm ruler. I've seen a scientific article about carbon dioxide values inside a surgical mask done with a measuring device which requires a 2-minute stabilization time for each measurement. I assume that you will see the problem with use of that kind of a device in the measurement. One example of measurement error is the superluminous neutrinos detected in 2011. Opera group was measuring tau neutrino properties from a beam of neutrinos launched from CERN in Geneva, which is in border between Switzerland and France, towards Gran Sasso, which is in central Italy. First measurement gave faster than light neutrinos, and carefully worded preprint was published. Second measurement confirmed the results, and there were lots of papers published in the theoretical side explaining the results. But later on, a loose cable in the setup was found, and also a faulty clock in the equipment was also detected. After corrections to the calculations, the end result was that neutrinos are not superluminous. Here you can see some images of the faulty connector. This episode shows the need for skepticism towards the data if the results are unexpected, even when the measurements are done by extremely trustworthy party. Another common type of error is a conversion error. There are multiple examples of this, and I just selected these two as an examples. Gimli Glider is a 767 aircraft which, due to a malfunctioning fuel gauge, had to manually input amount of fuel to the navigation computer, and there was a conversion error. The aircraft ran out of the fuel while flying over Canada, but luckily managed to land in a unused airport at Gimli. Mars Climate Orbiter crashed in Mars due to NASA using metric, and the builder of the probe, Lockheed Martin, used US customary units. This was a costly error in both money and time, and it shows that even experts are capable of messing up simple things. Next up is errors in computers when the actual input data was good. Cosmic rays can corrupt the data by flipping 0 to 1 or vice versa. Actually, the physics department has a laboratory just for studying these effects in the other side of the lake here in Jyväskylä. And not all data errors come from outside of the code. Bad code can change the data inside, and one of the major examples of this is a integer overflow. It can have a huge effect, like with the Boeing 787, the electronics needed to be reset periodically prior to a software update to prevent integer overflow. Sometimes the error is just embarrassing, like in these two games. I was planning to bring up Nuclear Gandhi in the Civilization games to this discussion, but after reading about it, I found out that I had bad data in my head. It was not an integer overflow, but a myth and then an Easter egg in the later games of the series. Next up is centered around the vagueness of language and how it affects the results. How many blue cars are in the parking lot is a simple question when asked, but not if we start to think of it. First thing, what is exactly the color blue? Is it some exact wavelength? Range of wavelengths? In dark, if you just see some blackness and you know that there's a car, is it blue or not? If you don't have enough information coming to your eyes. And there are also azure, purple and stuff like that. Are they blue or not? But it goes to the wavelength stuff too. Second, how is the parking lot defined? Does it include the garage which is next to it? Neighboring parking lots used by the university? Neighboring parking lots in non-university buildings? Surveys and polling also prove the vagueness of the language, and they have their own issues too. Wording in a poll will have a huge effect on the results. Is it morally acceptable to murder unborns? Or is it our responsibility to save the mother's life in the case of failed pregnancy? Participant selection skews the result, and you will definitely get different results when asking about the education level of the people at university building entrance versus the people at discount shop entrance. Scales based on the subjective issues are also troublesome. How painful it is to follow this presentation in the scale 1 to 10. Previous experiences defines the maximum pain level for each person individually. Data collection in a computerized system from users and multiple competing standards for transliteration of the ASCII is notorious for generating bad data. Let us see how a single Chinese name can be written with different ASCII-based transliteration standards. English, German, Finnish, and so on have their own standards, and they may even have been changed while time has gone forward. And these all are the same person. How often they would be categorized as different persons? Then to actual data collection on the internet. How many times have you been asked in which US state you live in? How many persons are born in January 1st, 18 years ago? And automatic user location tracking and filtering based on the IP doesn't work, as the VPNs are now being used more often. And now to the examples of how bad data affects the training of an AI. Shortcut learning is one of the major mistakes which AI does when it is trained with bad data. The shortcut learning in deep neural networks by Geirhos et al. Is a great source for more information on this. One of the most common examples is labeling new data based on the irrelevant information. For example, if all green hills in the data has had a flock of sheep in them, then the system can have an error shortcut stating that all images with green hills should be labeled as a flock of sheep, regardless of the actual presence of the sheep. The healthcare chest X-rays are often used in a computerized diagnosis. More than once, bad data practices have caused issues in this, like using the metadata inside of the image as a deciding factor when giving a diagnosis rather than the actual lung area. I will return to this subject on a later slide. Here are some more errors made by AI, which are most likely caused by bad data in the training. I have no idea what kind of data has been used for system to recommend substituting tampons with mushrooms. For automatic camera to mistake a bald referee as a ball is understandable if in its training material it has not had any bald referees or players. Racist AIs are way too common. If all data is coming from Western world, the AI will make errors for other ethnicities, like not realizing that the person's eyes are actually not closed in the image. And due to racial bias from the data, the healthcare algorithms are reinforcing this bias. One of the most common datasets used as an X-ray data for COVID-19 detection was composed in such a way that all of the X-rays of children in the training data are in the non-COVID set. This causes all systems to automatically assign children with non-COVID status regardless of the actual reality. Testing has also showed that many of the COVID diagnosis models don't even look at the lung area of the data, but other regions for the diagnostics. ChatGPT is one of the current hot topics in the AI world, and even outside of it. So-called glitch tokens can produce weird results, as you can see here. These are most likely a result of data issues resulting from indiscriminate scavenging of internet for the textual data. As you saw, the certain terms cause ChatGPT to produce gibberish. And this is an ongoing research area outside of my expertise. And here's a good starting point to learn about these issues. And besides of the accidentally bad data, we have to be on lookout for actual fraudulent data with malicious intent. Election fraud is often in the news, and no one is surprised that the dictator had 100% support. Other frauds like pump and dump scam with markets or insurance or tax frauds are also common. One newer thing is hybrid warfare and poisoning attacks against AI. The Taxonomy can be considered as an example of this. One license plate with null in it resulted a hacker to receive all tickets in which the system couldn't read the license plate and assigned null value to it. This can be seen both as an attack against the computer system and as a bad code inside of the system. The Babu tables is a classic XKCD comic about SQL injections as an attack vector. There are some solutions or partial solutions for this problem, and there are tools to improve the AI independent of the data. One of the new approaches is so-called physics or knowledge-informed deep learning. The informed machine learning, a taxonomy and survey of integrating prior knowledge into learning systems by Rueden et al. Is a good starting point for learning about them. Causality information is a second way of improving an AI. There are multiple implementations and ideas around this. For a nice overview of the causality in general, I suggest The Book of Why by Julia Pearl. Last but not least, the idea of using the explainability. Here I refer to these two free books, Interpretable Machine Learning by Molnar and Explanatory Model Analysis by Picek and Burzykovsky. But the true solution is to know your data. You need to verify, check and double check the data and the results. The explainability of your results is one of the key factors here. And a classic of strategical thinking, The Art of War by Sun Tzu states: if you know the enemy, the results, and you know yourself, the data, you need not fear the result of 100 battles or quality of your model. But as a final thought, I give you a quote from Stalin and my thoughts about it. I consider it completely unimportant who in the party will vote or how. But what is extraordinarily important is this: who will count the votes and how. We as the data professionals are the vote counters, and we must make the product as safe and fair as possible. Thank you.